Welcome to my new calculus channel. My name is John Gabriel. In this episode, or in this YouTube video, I'd like to discuss material implication. And there is a general consensus amongst the mainstream that any conditional, any logical conditional, such as if-then, can be replaced by the logical or the material implication in propositional logic. Well, it turns out that if you look at this epsilon-delta definition here, for every possible function except the constant function, this implication here also acts as logical entailment. So we could also write, for any function except a constant function, we could write that 0 is less than the distance between x and c, and the entailment is that f of x minus L is less than epsilon. The only time that can't be done is if you have f of x is equal to k. So let's take a look at an example of that. So let's change the function that we have here to a constant function as follows. Let's make it f of x is equal to 2. Now you'll see that this implication, this statement here is still true, but only in this particular case is it true, and it doesn't really satisfy all the conditions, and one important condition in particular. What condition is that? Well, you cannot have an epsilon greater than 0 that lies on this curve. Okay, so for example, let's come over here. You cannot have an epsilon greater than 0. There is no epsilon greater than 0 such that f of c plus e or f of c minus e exist. In the case of the constant function, neither this nor that exists. So it's totally irrelevant even to talk about epsilon in this case. The if-then conditional is best represented by a logical entailment, rather than an implication. Okay, so this is better than an implication. But in the case of the constant function here, this wouldn't work because there is no causal relationship between the antecedent and the consequent statements. Now, if you look at this diagram here, it makes no difference. For example, the effect of delta on epsilon is null and void. That's because there is no epsilon greater than 0 anyway. So this statement here becomes completely irrelevant. It says for epsilon greater than 0, but there are no epsilon greater than 0 that lie on this curve. There are none. Okay, so because it's a constant curve, all the epsilons must be 0, but that's not allowed in the definition. So this particular statement here again, in terms of epsilon x, fails in terms of the constant function for the very reason that, as I discussed a minute ago, neither f of c plus epsilon nor f of c minus epsilon exist if epsilon is greater than 0. So epsilon is greater than 0 becomes totally irrelevant. Of course, the mainstream academic morons never realized this, and just in their ignorance and stupidity just went ahead and said that the if-then conditional can simply be replaced by the material implication. And that's simply not true. Well, this is all I wanted to talk about in this particular video. I hope you enjoyed it. This is the New Calculus channel. My name is John Gabriel. Till next time, goodbye.